Hi viewers, welcome to my YouTube channel Math Tutorial. Today I am going to teach you 10th class syllabus arithmetic progression. In short form we will call it as a AP chapter 5. Some important notes, if anyone come across doubts during my class, please comment your query in the comment box. I will clarify your doubts. Please do like my channel, share my video to your loved ones including friends and relatives. Subscribe my channel, click on the bell icon to get the notifications to see many more videos on maths. Okay. Let us start our chapter. An arithmetic progression is a list of numbers in which each term, I will explain you what is meant by term. By uptime, is obtained by adding a D to the preceding term. Except the first term. For the first term there is no preceding term. The fixed number D is called the common difference. You must have observed that in the nature many things will follow a certain pattern. You will see some of the patterns. Consider the following list of numbers: 1, 2, 3, 4 and so on. Hundred, 90, 80, 70 and so on. Three, it is in a certain pattern. -3, -2, -1, 0 and so on. Each of the numbers in the list is called a term. I told you, no? Suppose 2 is a term in the pattern, 90 is a term in this pattern, 3 is a term in this pattern, 0 is a term in this pattern. In an AP, in an arithmetic progression, with first term is called A, is denoted by, first term is denoted by A, and common difference is denoted by D. First term is denoted by A and common difference is denoted by D. Then the nth term is given by an is equal to a plus n minus 1 into d. This is the formula. Everyone has to remember it, by heart it. With this formula, we will start some example. Reena applied for a job. Reena is applied for a job and got selected. She was given monthly salary of rupees 10,000 and an annual increment rupees 1,000 to her salary. Find the salary of the second, third, fourth year. Here, initial salary is 10,000. That means that is first year salary is nothing but A, that is equal to 10,000, and annual increment is nothing but common difference, that is denoted by D, that is equal to annual increment is rupees 1,000, that is D is 1,000. Remember, AN is equal to A plus n minus 1 into D. Now already A1 is first year salary, that is equal to 10,000. Now we would like to know second year salary, that is nothing but A2, that is equal to, here A is 10,000 plus n is 2, that is second year, minus 1 into D is 100. 1,000. Second year salary A2 is equal to 10,000 plus 1 into 1,000, that is equal to 11,000. Similarly, third year salary A3 is equal to, A is fixed, A is 10,000 plus third year, so n becomes 3 minus 1 into 1,000, that is equal to 10,000 plus 2 into 1,000, that is equal to 12,000. Similarly, fourth year salary A4 is equal to 10,000 plus 4 minus 1 into 1,000. Here n is equal to 4. 10,000 plus 3 into 1,000, that is equal to 30,000. So her. So Reena's first, second, third, fourth year salaries will be 10,000, 11,000, 12,000 and 30,000 respectively. So we need to remember this formula for finding the nth term. In that, A is the first term and D is the common difference, N is the nth term. The sum of first n terms of an arithmetic progression is given by n by 2 into first term plus n minus 1 into d. We will find out whether this formula holds good or not. We will see some pattern. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 terms are there. We are going to add by using this formula. Here n is equal to 10, a is equal to, this is a is equal to 1 and d is equal to, subtract any two adjacent numbers, that is 2 minus 1 is 1 or 9 minus 8 is 1. So here the sum of first term 10 terms is equal to, here n is 10, 10 by 2, 2 into a is, first term is 1 plus n is 10 here, 10 minus 1 into difference is 1, that is equal to 5 into 2 plus 9. 5 into 11 is equal to 45. So the sum of first 10 terms is 1 plus 2 plus 3 plus 4 plus 6 plus 7 plus 8 plus 9 plus 10 is equal to 55. If you find 15 plus 20, if you want to find out 15 plus 25 plus 35 plus 45 plus 55, then it will be very difficult. Here n is equal to 15, first term is 15, n is, number of terms is 1, 2, 3, 4, 5. Here there are 5 terms are there. A is equal to 15 and D is equal to, common difference is 25 minus 15, that is equal to 10. So the sum of first 5 terms is equal to, here n is 5 divided by 2, 2 into first term, that is 15 plus n is 5, 5 minus 1 into difference is D is 10. 5 by 2 into 30 plus 40. 5 by 2 into 70. 5 into 35 and is equal to 175. So by using this formula we can add n number of terms. We would like to know two formulas. If first term and last term is given, how to find out the sum and how to find out the common difference, we'll see now. If first term is given and it is denoted by A, the last term is given and is denoted by L, then the sum of the arithmetic progression is given by S is equal to number of terms divided by 2 into first term plus last term. To find out the common difference. To find out the common difference, T, subtract first term A from the last term is denoted by L, and then divide the value by the number of terms in that pattern minus 1, that is equal to n minus 1. So here to find out the common difference D, subtract first term from the last term. So D is equal to L minus A and then divided by number of terms n minus 1. Okay, if first term is given and last term is given, then the sum is equal to number of terms divided by 2 into A plus L. To find out the common difference, last term minus first term divided by number of terms minus 1. We would like to solve one problem based on the above two equations. The problem has already written over here. A wooden ladder has 25 centimeters apart. A wooden ladder has rungs 25 centimeters apart. That means each rung is having a spacing of 25 centimeters. First rung is 25, second rung is 25, like that every 25 meters there is a rung. The rungs decrease uniformly in length from 45 centimeters at the bottom to the top becomes 25 centimeters. So every rung some reduction is there. We want to know some fixed number. What is that fixed number of reduction? So that will be called as a common difference. If you find out, so by using the above formula, first term is given, last term is given, and number of terms also we need to identify. So in this above formula we need to find out n first. How to find out the n? N means we would like to know how many rungs are there in this ladder. First, number of rungs is equal to, we don't know how many rungs are there. Total length between rungs divided by distance between the rungs. Here we have to add plus 1. I will tell you why we need to add plus 1 here. Total length of the rungs is, total length between the rungs is 2.5 meter divided by 25 centimeter plus 1, that is equal to 250 centimeters divided by 25 centimeters plus 1. 25 ones, 25 tens. So 10 plus 1 is equal to 11. First term or first run. A is equal to 45 centimeters. Last term or last rung. L is equal to 25 centimeters. Then by using the above formula, common difference D is equal to L minus A divided by N minus 1. That is equal to, here L is equal to 25 minus 45 divided by N is equal to 11 minus 1. That is equal to minus 25 divided by 10. That is equal to minus 20. 25 minus 45 is minus 20 divided by 10. That is equal to minus 2. Here the common difference is minus 2. Then what we need to find? What is the length of the wood required for the rungs? So total rungs is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. First rung is 45. Last rung is 25. We have to add all. We have to add all rungs, then only we will get the length of the ladder. So we know common difference is minus 2. So we have to reduce 43, 41. Like that we have to reduce 39, 37, 35, 33, 31, 29, 27. So we got first rung, second rung, third rung, fourth rung, fifth rung, sixth rung, seventh, eighth, ninth, 10th and 11th rung. So by using the above formula, sum is equal to length of the wood. For making the rungs, S is equal to n by 2 into A plus L. Here n is equal to 11. 11 by 2 into first term is 45 plus 25. That is equal to 11 by 2 into 70. 2 ones to 35. That is equal to 385 centimeters. This is the length of the wood. These type of problems will oftenly come in the competitive exams. Find the 20th term from the last term of the arithmetic progression 3, 8, 13 and so on up to 253. In this problem, first term is given a is equal to 23. Last term L is equal to 253. Common difference T is equal to 8 minus 3, that is equal to 5. So we got 3. We need to know number of terms. We would like to know how to find out the number of terms in the arithmetic progression. Number of terms in a arithmetic progression is equal to last term minus first term divided by common difference plus 1. Why we will add plus 1, I will explain you in a few minutes time. Last term is 253 minus first term is 3 divided by common difference is 5 plus 1, that is equal to 250 by 5 plus 1, that is equal to 5 ones 5 50s. 50 plus 1 is equal to 51. I will just explain you why we will add 1 over here. Simple example, we will take it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Similar formula we will apply over here. Without adding 1, we will find out how many number of terms will come. Last term is 10. First term is 1. Common difference is 1. That is equal to 9 by 1. That is equal to 9 terms. But here 10 terms are said. That's why I have added 1 to the last. So this is the formula. Need to remember by everyone. We have to add plus 1 over here. Here some criticality is there. 20th term from the last term. So from the last it is 20th. From the first it is how much term we have to identify. Similarly here the same above formula. So we need to find out L20. L20 is equal to L minus n minus 1 into d. Here L is equal to 253 minus n is equal to 20 minus 1 into d. 253 minus 19 into 5. 253 minus 95, that is equal to 158. Similarly, how to find from the first. We'll see the same example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A1, A2, A3, A4, A5, A6, A7, A8, A9, A10. L1, L2, L3, L4, L5, L6, L7, L8, L9, L10. Here there are only 10 terms are there. You see here from the first it is 10th term. Here it is 11th term. If you add these two, total becomes 11. Here 9 from the first last two. So 11 terms are there. For everything there is, we need to add plus 1. Similarly, this is the 20th term from the last. From the first it will become how much? 51 minus 20 plus 1. Because one extra is there. For each and every term there is a one extra term. So here 11 is there. Total 10 terms are there. If we add these two, total 11 will come. Here 51 minus 20 is 31 plus 1, that is equal to 32. If we add these two, 20 plus 32, that is equal to 52. So actual terms is 51. So we have to add one more. Similarly, to find the, so from the first it will becomes A32 becomes here A plus. So we are adding. Here we are decreasing. From the last it is in a decreasing mode. From the first it is increasing mode. So A plus n minus 1 into D. A is 3 plus 32 minus 1 into common difference is 5. 3 plus 31 into 5. That is equal to 3 plus 153. That is equal to 158. We'll solve one more problem in arithmetic progressions. This type of problems will come in the competitive exams as well. Please concentrate. Check whether 501 will be the term in the list of numbers in the pattern 6, 13, 20, 27 and so on. If not, if 501 is not in that list, find the nearest number to 501. After finding the nearest number, find which term is that number. Okay. Here, let us assume let us assume 501 is the last term in that pattern. So first number A is equal to 6. Last number L is equal to 501. Common difference is equal to 13 minus 6, that is equal to 7. Is equal to 7. Common difference is equal to last term minus first term divided by n minus 1. Here D, we know that it is 7 is equal to L. We are assuming L is, here L is 501 minus A is first term, that is 6 divided by n minus 1. we'll cross multiply. N minus 1 is equal to 501 minus 6 by 7, that is equal to 495 by 7. We will divide 495, 7 7s are 49, remainder is 5. So 501 is not a 495 is not divisible by 7, hence 501 is not the term in the pattern. The pattern 6, 13, 20, 27 and so on. So we got one answer. Then what will be the nearest number? If we add 2 to this number, that means if we add 2 to this number, that means we have to add 2 to the original number. Then what will become here? 497. If we add 2, 7 7s are 49. Remainder is 1, 7 1s are 7, that is equal to 0. So if we add 2 to the last number, that is 501 plus 2 is equal to 503, then so the nearest number to 501 is 503. Then 503 is in the, then 503 is in the pattern. 6, 13, 20, 27 and so on, 503. We need to find the term in that. 503 is the which term in that pattern. Now the corrected last number is 503. L is equal to 503, A is equal to 6, D is equal to 7. By using the above formula, D is equal to L minus A divided by N minus 1. D is 7, L is 503 minus 6 divided by N minus 1. We have to cross multiply. N minus 1 is equal to 503 minus 6 divided by 7, that is equal to 497 by 7, that is equal to 71. N minus 1 is equal to 71, N is equal to 72. 503 is the 72nd term in the pattern. Six, 13, 20, 27 and so on. So we got the 3 answers. This way we have to solve the problems. Thank you so much. Hi viewers, thanks for your patience for watching my video. In this chapter 5 of class 10, arithmetic progression, we have covered the syllabus, definition of arithmetic progression, some examples of arithmetic progressions, and we have learned some formulas for finding the nth term, sum of n terms of an arithmetic progression, and formula for finding the common difference if first and last term are given. And we have solved some problems of arithmetic progression by using different formulas. If anyone come across any doubts, please comment in the comment box. I will clarify your doubts. Thanks for watching.